In this video, we're going to go through the answers to the entry ticket for Week 8, Lesson 3. This entry ticket is composed of 4 questions. Question 1, prime factor trees. Question 2, Pythagoras' theorem. Question 3, reading decimals or writing decimals as they are read. Question 4, problem solving from worded problems. Let's go to question 1. Question 1 is, use prime factor trees to factorize the following, the verb being factorize. So we need to break these numbers here into their prime factors. Now to do this, I'll remind myself the first few primes. I know the first one is 2, then there's 3, 5, 7, 11, 13, 17, and 19. I could go higher, but I'm unlikely to have to use numbers higher than this because I'm not using a calculator for these problems here. So this should be fine for now. Next, what I'm going to do is I'm going to start with 40 over here, and I'm going to pick the first prime, which is 2. And I'm going to ask the question, can I divide 45 by 2 and get a whole number result? And the answer is no, I cannot. So what this means is that 2 is not a factor of 45. Next, I turn my attention to 3. I ask myself, can I divide 45 by 3? And the answer to that is yes. If I divide 45 by 3, I'm going to get a leftover of 15. So perfect. Next, I was able to divide by 3, so I'm going to try again. I ask the question, can I divide 15 by 3? And of course the answer is yes. I get 3 and 5. 5 is my working number, and I ask, can I divide it by 3? And no, I can't. So I keep going down and I see I've got 5 on my list next. Now because 5 appears on the list, what this means is that I have found all my prime factors for the number 45. That being, the prime factors of 45 are 3 by 3 by 5, or 3 squared times 5. Okay, moving along. 40. I turn my attention to the first prime in the list, which is 2, and I ask the question, can I divide 40 by 2? The answer to this is yes. If I divide 40 by 2, I get a result of 20. Now because 2 worked once, I'm going to try and do it again. Can I divide 20 by 2? And the answer of course is yes. I get 2 and 10. Again, can I divide 10 by 2? The answer is yes. I get 2 and 5. And because 5 is a prime number on my prime list, I know I can stop from here. So my factors for 40 are 2 by 2 by 2 by 5, which can be rewritten as 2 to the power of 3 times 5. Next question. I have 29. I ask myself, can I divide 29 by 2? And the answer is no. 3, the answer is no, I cannot. 5, no. 7, no. 11, no. 13, no. And then 17. If I try and divide 29 by 17, I see it doesn't work. Now, it's at this point I know to stop, because if I think about the numbers I'm working with here, 17 multiplied by 2 is going to give me 4 plus a 1, 2 times 1 is 2, and the 3. Because 34 is larger than 29, what I find is that if I try and divide 29 by any of the numbers after 17, they won't actually fit. And because of that, what I decide is that 29 is a prime number. So it actually belongs on this list over here. or the list going down over there. So that's as factorized as it's going to get with these three numbers. So question 1 complete. Question 2, determine the unknown side lengths. I am cued with a right angle triangle. Whenever I see one of these, I always look for the right angle, which is shown by this symbol here. Once I identify the right angle, I always draw an arrow pointing outwards from the right angle, and this always reveals to me the side I call C. Now, I label the other sides A and B. Doesn't matter what side is what, so long as one's A, so long as one's B. Next, Pythagoras' theorem is C squared equals A squared plus B squared. Now I sub in my values. I have C, which is 29 squared. A is going to become 20, so it's 20 squared. And then B, which is U. Now at this point, I'm in the situation where my unknown is hanging out on the right hand side with a number over here. We don't like this because what it means is that we don't have U isolated. So what we do is we take away everything that's hanging out with U. So I take 20 squared from both sides. It's going to give me 29 squared take 20 squared, and U squared is now on the left because I've just got in this side, moved it that side, this side, moved it that side. Now I need to start evaluating these values here. To do this, what I say is come to my calculator and I just key in the values. So 29 times 29 will give me 841, and the next one, 20 squared, should give me 400. I still have U squared on the left. Working my way down, I have 841 take 400, that's going to be 441. And now I want to know the result of U, not U squared. So what I do is I take the square root of both sides. This will have the effect of cancelling out the square operation on the left. This becomes U. Looking at the square root of 441, I put in 441, then hit the square root button, and I get 21. So, the side length of U in this instance is going to be 21, and the units are dogs. That's question 2A. Let's go to B. We are presented with another right angle triangle. I start this problem by identifying the right angle as shown here. I then draw an arrow pointing outwards from the right angle, and I know that this always points to the side length that needs to be labelled C. The other two side lengths can be called A and B. It doesn't matter which one's A and which one's B. Next, I state Pythagoras' theorem. C squared equals A squared plus B squared. After which, I start the substitution. So my C in this instance is T. So I put in T squared. My A is 142 squared. And my B is 120 squared. Now these are really big numbers, so again I need to use my calculator. 142 times 142. That gives me 20,164. Plus, we're going to go 120, and I'll just use the square operation. 14,400. This is still T squared. Next, I add them together. 1440 or 14,400's in there, so I'll just go plus 20,164. This gives me 34,564. This is still T squared. Now, I don't care what T squared is, rather I care what T is. So what I do is I take the square root of both sides of the equation. The square root of T squared is just T. The square root of 34,564 is 185.91395 blah blah blah. Now, to this point I need to make a decision. How many decimal places do I want? If I'm working in dogs, then, well, I don't know what a portion of a dog is. So what I'm going to do is I'm going to round. So I have 185. And I'm going to round to the nearest dog. So it's going to be 0.9. Looking at this, I want to round to the nearest dog. So for ones, I go back one. And I think, is 9 greater than or equal to 5? It is, so it's going to go up. Hence, it's going to be 186 dogs. Perfect. If you got this far, then we'll give it a tick. If you got some sort of value here, we'll give it a tick. And if you got this far, we give it a tick. But so as long as you get up to here, that's pretty good. Alright. So solution for this one was square root of 34,564, or you could have said something like 186 dogs. Moving down, question 3. Write the following as they are read. We have for A, 0.30. Now looking at this, I always look at the first digit to the left of the decimal point, and I see this is 0, so I don't have to write anything. The next I see is decimal point. Now because everything to the left is 0, I don't write anything for that either. Rather, I look to the right and I see the number 30, so I write 30. Next I look at my place value. I have tenths, then I have hundredths. So what I'm going to say is this is 30 moving along. Same method. I have a negative out there. I might just change the color. Negative. So I need to write negative. After which, I have a 0, so I don't need to write anything. Decimal place, because there was a 0 in front of the decimal place, I don't need to write anything. And then I have 52. So I write negative 52. And then looking at my place value, I've got tenths, hundredths, thousandths. Alright, final one, C. Let's have a look. We start off and we have a negative. So we write negative. After which, we have a decimal place, or number in front of the decimal place. So the number is non-zero, so we're going to write 3. And then because we had a 3 in front of the decimal place, we have to represent the end in place of the decimal place. Moving along, we have the number 2,501. And then the place value, we have tenths, hundredths, thousandths, tens of thousandths. Thus concluding our final one. So in summary, on the most complicated example, we have a negative, so we drop the negative. We have a number to the left of the decimal place that's non-zero, so we write the number, in this case 3. Because we had to put the 3 down, we have to convert the decimal place to an end, followed by the number we read to the right of the decimal place and its place value. Moving along. Question 4. Worded question. Bobo walked 5 kilometers before turning right and walking another 4 kilometers. How far is Bobo from his original starting location? Okay, so we're going to use the cubes model here. Cubes model being, circle the numbers. So I see the 5 kilometers. I see 4 kilometers. Next, I am going to underline the question at hand. Bobo walked 5 kilometers before turning right and walking another 4 kilometers. How far is Bobo from his original starting location? So I underline the how far is Bobo. Next step, we've underlined. Now we need to box up the important features. So I believe this is done. We'll do this in green. So Bobo walked, turning right, walking another, and that's all of it. And then finally, for working on this, we need to strike out all the stuff we don't need. So we don't need Bobo, we don't need before, and we don't need and. So if we read this again based on what we have walked 5 kilometers, turning right, walking another 4 kilometers. So building a diagram from this, I will go, we'll go this way, and this represents Bobo's starting location. You turn right, he went this way. So arrows, arrows. Assume it's 90 degrees. Then distance from the starting location is the dotted line. So this is Bobo. Happy. Okay, putting the numbers on here. He walked 5 kilometers. He then walked 4 kilometers. How far is he from his starting location? That's represented by this line over here. So we're going to call this F, because why not? Okay, we now have a triangle, so we're dealing with Pythagoras' theorem. When we see this, we always identify the right angle, which is here. So I draw an arrow out, and this will tell me which side I should call C. In this case, it's the side with the length F. Next one, so we're going to go A and B, remembering that A and B do not matter. You can call B A and A B, or A B and B A. All that matters is C is labelled correctly. Next, Pythagoras' theorem is C squared equals A squared plus B squared. I sub in my values. C is represented by the F, A is the 4, B is the 5. Evaluating, 4 squared is 16, 5 squared is 25. Next, we're going to have still F squared on the left, and then 16 plus 25 is going to be 31. Now I don't care what F squared is, rather I care what F is. So what I'm going to do is I'm going to square root both sides. Thus, pen color. Therefore, F is going to be the square root of square root of 31. Now I want to work that out, so I just bring up the calculator. 31 square rooted. So it's 5.57. 5.567. So I just say 5.57. Yeah. Kilometers. And there's our answer. We say Bobo is 5 point from his starting location. So this is our answer. So to summarize what's happened here, we've had a worded question. We analyze it using the cubes framework. Circle the numbers, underline the question at hand, box up the keywords, eliminate the words that are none, or the words that are left over, so the unnecessary ones, and then you just solve it. So reading this out again, it's clear as day that we're drawing a triangle. Because we've got a right angled triangle, we know to use Pythagoras' theorem, which reveals to us the distance Bobo is from his starting location.